Hi everyone, welcome to the OneClass channel. My name is Marlyn. I'm a second year student at the University of Waterloo studying chemical physics with a minor in math. Today I'm going to be going through some high school level and college level calculus problems. Be sure to check out the links in the description if you're in need of any extra homework help or like some one-on-one tutoring. Okay, let's jump right into it. So for our first question, we are asked to find, without using a calculator, the absolute extreme value of the function on the given interval. And the function is f of x is equal to x over x squared plus 9. Okay, so as a general example, sorry about that. Let's take this function, right? Now we know that the derivative of a function at a certain point is its instantaneous rate of change. So for example here, the derivative should be positive because the slope of this line is positive. Here, the derivative should be 0 because the slope of this line is 0. Here, the derivative should be negative because the slope of this line is negative. So the derivative of the function describes the slope of the tangent line at that point. And so that means that if you want to find the extreme value, so the extreme values are points like here and here, we simply need to find values at which the derivative of the function is 0, because at both of these points, the function is changing, whether it's increasing or decreasing, and it's reaching a point where the slope of the function at that point is 0. So what that means is that to answer this question, I first need to find the derivative of x over x squared plus 9. In order to do this, I just need to remember the quotient rule, and that just states that the derivative of f of x over g of x is the derivative of x by g of x minus the derivative of g by f of x all over g of x squared. And so if f of x is equal to x, the derivative of that is 1. And if g of x is equal to x squared plus 9, the derivative of that is 2x. And so we're just going to plug in all of that into our formula to get that the derivative of x over x squared plus 9 is going to be 1 by x squared plus 9 minus 2x into x, all over x squared plus 9 squared. This is going to give us x squared plus 9 minus 2x squared, all over x squared plus 9 squared. And this is going to give us 9 minus x squared over x squared plus 9 squared. So this is going to be our derivative of the function. So if we want to find the slope of the tangent line at x is equal to a, we just put in a for the x value here, and it will spit back out the slope. And so as we know, and we discovered up here, if we want to find x at which we have an extreme value, simply find the points at which the derivative, so the slope of the tangent line, is 0. And so let's plug that into what we found the derivative to be. And this can only happen when the numerator is equal to 0. That means 9 minus x squared is equal to 0. And this will give us x squared is equal to 9, which will give us x is equal to positive or negative 3. So we have extrema at x is equal to positive or negative 3. Let's find out what our values of f prime of x before and after these points are. So if you just draw the number line really quick, we have -3 as a point, 0, and +3. And so you want to find out what the slope looks like in between here, before that point, and after that point. And so put in a value less than -3, so e.g. -4, and you will get 9 minus -4 squared over x squared plus 9 squared. And this will give us 9 minus -7 over 625. The point is that it's less than 0. Let's check in between -3 and +3. So for example, 0. And we'll get 9 minus 0 over 0 plus 9 squared. And this will give us 9 divided by 9 squared. And that's simply going to give us 1 over 9. The point is that it's above 0. And lastly, let's check a point past +3, like +4. And that's going to give us 9 minus 4 squared over 4 squared plus 9 all squared. And this will again give us -7 over 625. Again, the point is just that it's less than 0. So as we found before, here, when the slope is positive, for example here, if f of x is greater than 0, that means f of x is increasing. And if f prime x is less than 0, that means f of x is decreasing. So, in order to determine what points are maxima or minima, we just use all of these facts. And so we have that from before -3, the slope is negative. You hit -3 where you have a 0, and then it becomes positive, and so it starts increasing. And then you hit +3, and it begins decreasing again. What that means is that +3 is going to be an absolute max, and -3 is going to be an absolute min. And so now we just find our f of x values at each of them. So f of 3 is equal to 3 over 3 squared plus 9. So 1 over 6, and f of -3 is going to be -3 over -3 squared plus 9. And this will give us -1 over 6. So we will have an absolute maximum at x is equal to 3, and therefore f of x is equal to 1 over 6, and an absolute minimum at x is equal to -3, and f of x is equal to -1 over 6. If you'd like to just ensure that your answer is correct, you can quickly pull up decimals and just graph our function. We have x over x squared plus 9. And so you see here, we have a minimum value at -3, -0.16 recurring, which is 1 over 6. So -3, -1 over 6, and a maximum at 3, 1 over 6, exactly what we found. And so this is going to be your final answer. On to our next question, we want to use the binomial series to expand a certain expression. First, you need to write down what the binomial series is, and it just states that a plus b to the power of n can be represented by the summation from n is equal to, my apologies. So binomial theorem. Binomial series. And that just states that a plus b to the power of n can be rewritten as the expression of the summation from k is equal to 0 to n of n choose k, a to the power of n minus k, b to the power of k. So if we substitute in a is equal to 1 and x is equal to n, we will get the expression from k is equal to 0 to still n of n choose k, 1 to the power of n minus k, x to the power of k. Now, we know that 1 to the power of any function of x is always going to give you 1. And so we can just rewrite this as 1 times this, which is just this expression. And then we can decide to expand out to this, and this can be rewritten as n factorial over k factorial into n minus k factorial. And so let's go about doing that. N factorial over k factorial, n minus k factorial multiplied by x to the power of k. And this is going to be your final answer. If you want to write out the first couple of terms when k is 0, then you have n factorial over 0 factorial, which is 1. N minus k factorial is going to be n factorial into x to the power of 0, plus n k is equal to 1, so n factorial over 1 factorial n minus 1 factorial x to the power of 1, plus, and just keep going like that. So let's just write it out until the third term. And it would keep going until n. Keep going until n factorial over n factorial by 0 factorial x to the power of n. And so these would just cancel, so you could just be left with x to the power of n. And that's going to be your final answer. Next up, we want to find the average value of f in this function from 0 to 8. So in Calc 1, we learned that the average value of a function is 1 over the limits that we've created in those functions multiplied by the integral from a to b of f of x dx. And so in our scenario, we've limited it between 0 and 8, so 1 over 8 minus 0 multiplied by the integral from 0 to 8 of f of x dx. Now we know that the integral of f of x dx from 0 to 8 is just the area under the graph from 0 to 8. They've clearly illustrated the parts of the area from 0 to 8. So if we just add all of those up, we'll have the same thing as that expression. We know that the area under the graph is going to be 1 by a half, and that's going to be a half, but it's under the graph, so it's going to be negative a half. Area 2 is again going to be a half. Area 3 is again going to be a half. Area 4 is going to be 2 by 1 by a half, and that is going to give us 1. Area 5 is going to be 2 by 2, giving us 4. Area 6 is going to be 1 plus 1 over 2, giving us 3 over 2. And lastly, area 7 is going to be 1 plus the same thing here, so 1 plus 1, giving us 2. This means that the area under the graph from 0 to 8 f of x dx is going to be 1 plus 2 plus, you just add all of them up until 7, and that is going to be it's supposed to be 1 over 2. 1 over 2 plus 1 over 2 minus 1 over 2 plus 1 plus 4 plus 3 over 2 plus 2. These two will cancel, and these two will add up to 2. And so this will give us 2 plus 1 plus 4 plus 2. And this is going to give us 6 plus 3, 9. And so now we're just going to plug this back into our formula up here. And we'll get that the average value of our function is 1 over 8 multiplied by 9. And this is going to give us 9 over 8. And that is going to be a final answer. Next up, we want to integrate 1 plus dx over 1 minus dx over dx. And what we are going to do for this question is we're going to make the substitution that u is equal to e to the x. That means du over dx is equal to e to the x, which is u, which means that we can state dx is equal to du over u. We're going to plug all of that back into here so that we can get the integral of 1 plus u over 1 minus u by du over u. And that is just the integral of 1 plus u over u into 1 minus u du. Now we've converted it into a form that is solvable if we use partial fractions, and that is exactly what we're going to do. So we will simply state that 1 plus u over u into 1 minus u is the same thing as a over u plus b into 1 minus u. And then we're just going to solve for our a and b, and then separate this fraction using the rule that the integral of f of x plus g of x dx is the same thing as integrating them separately. Okay, so we solve for a and b by rewriting this as a into 1 minus u plus b into u over u into 1 minus u is equal to 1 plus u over 1 minus u. This will become a minus a u plus bu is equal to 1 plus u. We can just reorganize this as a plus b minus a u, which means that a must be equal to 1 and b minus a is equal to 1, which is equal to b minus 1. This will imply that b is equal to 2. Now, all of that will mean that the integral of 1 plus u over u into 1 minus u du is going to be the same thing as the integral of 1 over u plus 2 over 1 minus u du. We're going to separate these into the integral of 1 over u du plus the integral of 2 multiplied by 1 over 1 minus u du. And then, for this one, we already know that this is going to give us ln u. For this one, we're going to need to solve it. And we're going to solve it using, again, a substitution. If we set 1 minus u is equal to t, then dt over du is going to be negative 1, which means that du is equal to dt over negative 1. Which means that we can rewrite the integral of 1 over 1 minus u over du is equal to the integral of 1 over t du over minus 1. And this will be negative the integral of 1 over t. This will give us negative ln the magnitude of t, which will give us negative ln the magnitude of 1 minus u. And then, of course, we're going to multiply that by the 2. And so our final answer will be that not our final answer, but the answer for this part is going to be that the integral of 1 plus u over u into 1 minus u du is going to give us ln of u minus 2 ln of 1 minus u plus c. And then we're just going to put back our u as e to the power of x. This will become ln of e to the power of x minus 2 ln of 1 minus e to the power of x plus c. And then we'll just note that ln of e to the x is equal to log base e of e to the x, which is x, log base e, which is just x. And so this will become x minus 2 ln 1 minus e to the x plus c. And that is going to be your final answer. Next up, we want to integrate 1 over x. And this is a known integral. We know that the integral of 1 over u du is equal to ln of the magnitude of u, or you can state this as the derivative of ln u is equal to 1 over u. This means that the integral of 1 over x dx is going to give us ln the magnitude of x plus c. And that's going to be your final answer. Okay, next up, we want to integrate e to the u over 7 minus e to the u du. Here we're going to make a substitution. We're going to state that t is equal to 7 minus e to the u. So dt over du is just going to be negative e to the u, which implies that du is equal to dt over negative e to the u. This substitution was implied because we have it in the form f prime of x over f of x dx, which implied that we're going to be using this substitution. And so this will become the integral of e to the u over t dt over negative e to the u. These two cancel. This becomes the integral of negative 1 over t. Sorry, this is squared. So this will be t squared. So the integral of negative 1 over t squared dt. Okay, and this will become negative the integral of t to the negative 2 dt. We're going to be using the exponent rule for integral, where we know that the integral of x to the power of a over dx will be 1 over a plus 1, x to the power of a plus 1 plus c. We're going to apply that here, where we have a is equal to negative 2, a plus 1 is equal to negative 1. And so this will become negative 1, because of this negative out here, over negative 1, because of the a plus 1, by t to the power of negative 1 plus c. These two will cancel, and it will become 1 over t plus c as my final answer. I just want to substitute back in what I know t is, and this will become 1 over 7 minus e to the power of u plus c. And that's going to be my final answer. Next up, I want to find the area of the shaded region. I can do this using two methods. I can decide to use calc1, and that just tells me that the area in between them can be written as xi to xf of the top function minus the lower function all over dx. And so if I apply that to this question, I know that xi is equal to 1, xf is equal to 8. My top function is equal to the cube root of x, which is x to the power of 1 over 3. And my bottom function is equal to 1 over x. And so I'm just going to put that all back in here, and I will have the integral from 1 to 8 of the cube root of x minus 1 over x. This is all over dx. I'm going to use the integral property. That's the integral of f of x plus g of x all over dx is the same thing as taking the integral separately. And this simply lies in what integration is. The integral under a function, so for example, the integral under this line, this red line, I can either take the integral from 0 to 8, or I can decide to take pieces of the integral individually and add them. And so that's why this exists. And so that means that I'm going to rewrite this as the integral from 1 to 8 of the cube root of x minus, this is over dx, minus the integral from 1 to 8 of 1 over x over dx. This integral, I already know what it's going to be. It's going to be ln the magnitude of x. This one, I'm going to use another well-known rule for the exponents, and that is just going to be 1 over a plus 1 x to the power of a plus 1 plus c, which means that the integral of x to the power of 1 over 3 over dx is going to be 1 over 3 plus 1 is 4 over 3, x to the power of 4 over 3 plus c. And this can be rewritten as 3 over 4 by x to the power of 4 over 3 plus c. And so now when I combine all of that, that is going to give me that the area is going to be equal to 3 over 4x to the power of 4 over 3 minus the ln of the magnitude of x plus c. And that is going to be, plus c if it was unbounded, but it is bounded. Instead, I'm going to take this from 1 to 8, and it is going to be 3 over 4 8 to the power of 4 over 3 minus ln magnitude of 8, so just ln 8. And that is going to be minus 3 over 4, 1 to the power of 4 over 3, plus ln of 1. This is going to give me 0. This is going to be 1. And this is going to be 3 over 4 by 16 minus ln of 8 minus 1. This is going to give me 11 minus the ln of 8. Oh, my apologies. And that is going to give me a final answer of 8.920558. 458. Let me just make sure everything checks out. My apologies. This is 3 over 4. So that's going to be minus 3 over 4 instead. And that is going to give me 12 minus 3 over 4, which is 11.25 minus the ln of 8. And that is going to give me 9.170558458 as my final answer. The alternative method of doing this would be to take the, to do it all in one step, and that is by deciding that the area is equal to the integral of dA, and this is going to be the double integral of dA, and this is going to be you integrate over the area d dx dy. We need to define what our area d is, and it is in Cartesian coordinates, such that x is between 1 and 8, and f of x is between 1 over x and the cube root of x. And that's how you define your region D. And so you're going to take the integral from 1 to 8 and the integral from 1 over x to the cube root of x. dy, dx. You can do them in any order as long as these integrals are stated correctly. And so this will become the integral from 1 to 8 of the cube root of x minus y from 1 over x to the cube root of x over dx. And this will become the integral that we had using the calc 1 method. This is a calc 3 method. So the integral from 1 to 8 of cube root x minus 1 over x dx. And then you treat it in a similar fashion as we did to this and up here. The only difference between these two methods is the calc 1 method is derived from the calculus 3 method, and I'm stating what I'm basically stating in D mathematically with words using the calc 1 method. And that's simply because in calc 1 you probably haven't been taught the language that you would need to describe D. And that's it for this question. Okay, next up, I would like to convert the parametric equations into a Cartesian equation. And so I'm going to make use of the identity that sine squared t plus cos squared t is equal to 1. And so with the scenario where x is equal to sine squared t, I already have it in the form that I like. Next, in y is equal to 2 cos t, I'd like to solve for cos t. So this would become that cos t is equal to y over 2. And this would mean that cos squared t is equal to y squared over 4. So now I plug all of these back into this equation and it becomes x plus y squared over 4 is equal to 1. I'm going to multiply both sides of this equation by 4. So that it can become 4x plus y squared is equal to 4. Isolate for the y squared, so that you can get y squared is equal to 4 minus 4x, and then you're going to take the square root on both sides. So you can get y is equal to the square root of 4 minus 4x. And this would be your final answer for a Cartesian equation. If you want to better understand what it is describing, you can put it in the correct form. And the correct form would imply that, as I said, y squared is equal to 4 minus 4x, which can be written as negative 4x plus 4. And we can take out the common factors, so it becomes negative 4x minus 1. And this describes a parabola, y squared, a parabola with a vertex at 1, 0. And so you can give your answer in any of these two forms. This one is a little bit better because it gives the person reading your answer a better picture of what you're describing. Okay, next up, I would like to find a power series representation for ln of 1 plus x. Okay, so I know that ln of 1 plus x is equal to the integral of 1 over 1 plus x over dx. You can prove this by just substituting u is equal to 1 plus x, which means dx is equal to du. And so it just become the integral of 1 over u du, which would be ln u. And then you substitute back in the u and get ln 1 plus x. And so we know that ln 1 plus x is equal to this integral. And additionally, we know that 1 over 1 minus x can be stated as the summation from x is equal to 0 to infinity of x to the power of n. And so now let's find an expression for 1 plus x, and then we're going to integrate it to find the power series representation. And so 1 minus x for the 1 plus x. And so you just substitute minus x back in here. And this would become negative 1 to the power of n and x to the power of n. And so ln of 1 plus x is equal to the integral of the summation, so this power series, And these have no x dependence, but x to the power of n does, so that's what we're going to be integrating. I know that the integral of x to the power of a is 1 over a plus 1 x to the power of a plus 1. And so this will become the power series, negative 1 to the power of n, x to the power of n plus 1 over n plus 1. And that's going to be the power series representation of ln 1 plus x. Now, to find the power series representation of x ln 1 plus x, we're simply going to multiply this by x. So that is x multiplied by this power series. And that will, when you move it in, it will become x plus 2. And that's going to be your final answer for that part. Lastly, you want to find the power series of ln 1 plus x squared. And to do that, we're going to simply substitute x squared into our expression here. It becomes negative 1 to the power of n, x squared to the power of n plus 1 over n plus 1. And you know that x to the power of a by b will give us xab. And so applied to this, we get that this is equal to the summation from n is equal to 0 to infinity, negative 1 to the power of n, x to the power of 2n plus 2, all over n plus 1. And that's going to be your final answer. Okay, next up, we want to evaluate the integral by interpreting it in terms of area. So how we're going to do that is we need to understand what the integral is and then what we're finding depending on what's inside the integral. So we're integrating from 0 to 5 of 4 minus 2x dx. So I could go ahead and find out and plot this function, if I'd like, and integrate it from 0 to 5. So find the area under the graph from 0 to 5. And from this alone, I can tell that area is going to be negative because of the fact that the area above the x-axis, which is positive, is less than the area below the x-axis, which is negative. Alternatively, I can use integral properties to split the integral, and I can change this into the integral from 0 to 5 of 4 dx minus the integral from 0 to 5 of 2x dx. Now to do that, that would mean that I plot f of x is equal to 4, so y is equal to 4. And additionally, I'm going to plot y is equal to 2x. And what I want is I'm going to take the integral of, so the area under the blue line from 0 to 5 minus the area under the yellow line from 0 to 5. From this, again, I can tell I'm going to get a negative answer. This area is less than this area. And so it's going to be a smaller number minus a larger number, which is going to give me 0. And so the area under the graph from 0 to 5 of the blue line is simply going to be 4 by 5, which is going to give me 20. And that's going to be this part. If I want the area under 2x from 0 to 5, I can see that it is going to be a right angled triangle. So I can simply do 5 by 10 by 1 over 2. And that is going to give me 5 by 5, 25. And so this is going to become negative 5 as my final answer. I can prove that this is correct by taking the integral as I typically would. If I don't interpret it using the area. So this integral is going to give me x squared. And that is just, again, off of the premise that this is equal to 1 over a plus 1 x to the power of a plus 1. So the integral of 2x dx is going to be 1 over 1 plus 1, 2. And then remember, it's going to be multiplied by 2. So that's 2 over 2 multiplied by x squared. And so these two will cancel, just leaving the x squared. And so now I'm going to evaluate these, and it will become 4 by 5 minus 4 by 0 minus 5 squared minus 0 squared. And this becomes 4 by 5 minus 5 squared, which is a 20 minus 25 we initially found, and that is going to give us negative 5. And that's it for this question. Okay, so the graph of the derivative of a continuous function is shown. On what intervals is f increasing and decreasing? At what values does f have a local maximum, local minimum? On what intervals is f concave upward or concave downward? And state the x coordinates of any points of inflection, and lastly sketch the graph of f. And so let's just build our theory. You know that if we have a function like that, if the derivative is 0, because the derivative describes the slope of the tangent at that point, then we have extrema. If the derivative is positive, then we have an increasing function. If the derivative is negative, which is here, the slope is negative, then we have a decreasing function. And so let's start with that for our A. So here, we are given that the f of x is greater than 0 in these areas, so between 0 and 2, if you just look at the graph, between 4 and 6, and lastly between 8 and infinity. We're given that f prime x is less than 0 in the areas between 2 and 4, and in the areas between 6 and 8. Now, for our next question, we are asked to find any extrema, so any local maximums or minimums. So our extrema are going to be located, as we said, at the point where the derivative is 0, and that is at x is equal to 2, at x is equal to 4, and at x is equal to 8. Now, we need to determine whether they're going to be minima or maxima, and that will be dependent on this. So, of course, if it's increasing and then decreasing, as shown here, then we're going to have a maximum. If it's decreasing and then increasing, we're going to have a minimum. And so from at the point 2, it is going from increasing to decreasing because the derivative is going from positive to negative. And so that will mean that at x is equal to 2, we are going to have a maxima. At x is equal to 4, we are going from the slope of the tangent line being negative, so a decreasing function, to the slope of the tangent line being positive, so an increasing function. That means that this is going to be minima. And then lastly, at x is equal to 8, so this is 2, this is 4, at x is equal to 8, again, we are going from the slope of the tangent line is negative, so a decreasing function, to the slope of the tangent line is positive, so an increasing function. And so x is equal to 8 will also be a minima point. And so that is going to be our answer to point B. Now, when we begin talking about concave upward and concave downward, we need to start looking at the second derivative. And so what happens when you take the second derivative, so you're taking tangent lines to the function that you've been given, if the second derivative is greater than 0, you'll have a point that is going to be concave. You'll have the function being concave up. If the second derivative is less than 0, the function will be concave down. And so we see that between 0 and 3, if you just draw lines on this function, you see that we'll have a negative slope all along this point. So from 0 to 3, the second derivative is less than 0, and we have it being concave down. From 3 to 6, we have the opposite, so the second derivative is greater than 0, which means it is concave up. And then lastly, from 6 to 8, the second derivative is greater than 0, so concave up. So those are your answers to part C. Lastly, parts D, we're looking for points of inflection. The points of inflection also relates to the second derivative, and it's when the second derivative is equal to 0. So at what points here are in our function is the slope of the tangent line equal to 0? And we have that that is occurring at x is equal to 2. And so now with all of this information, we want to sketch the function, and luckily that has been done here for us. And so as said, we said the function was increasing until, my apologies. Okay, so we said that the function was increasing until 2, right? And then we said that at 2, we have a maximum, so we can see that right here. And then we said that past 2, so between 2 and 4, the function is decreasing. And so you can see that it begins decreasing. And then you need to note that we found a point of inflection at x is equal to 3. We can see that here. And then we see that past 4, so at 4, we have a minimum right here. And then beyond 4, so between 4 and 6, the function is increasing again. Increases all the way until 6. And then at 6, you can see in our function given that at 6 we have a discontinuity. And that is going to typically be caused by jumps, like the one that you're seeing here. So if you graph the second derivative of f, you'd get a similar jump at 6 because there's a jump in the first derivative of x. Or you can get these sharp points that look like this. Oops. Like this. And so that's exactly what we see here. We see that at 6, where we had this discontinuity in our f of x, it was actually caused by this point here. And then beyond 6, we see that the function should be decreasing. So from 6 to 8, the function is indeed decreasing. At 8, we have a minimum, and then the function begins increasing again. You can double check your concave up, concave down. So when so between 0 and 3, we had concave down, so it looks like a parabola facing down. From 3 to 6, we have concave up, which is true. And from 6 to 8, again, we have concave up. And so if we're going concave up and then concave up, we're bound to have this point that I previously discussed, where we had a discontinuity in our first derivatives graph. And so that's it for this question. Sorry, just one moment. Okay, for our next question, we want to match the parametric equations with the correct graph. And so we just need to study what this is describing in x, y, z coordinates, and then just match it to the correct graph. So our x is equal to t equals t is describing a sinusoidal function that is, in a sense, getting larger due to this multiplying it by t. So we should expect something that looks like this in the x direction. In the y direction, y is equal to t, we simply have a linear function. And so we should just expect something that is increasing linearly. And lastly, in our z direction, we have t sine t. And that is similar to what we had in our x, where we have it increasing that way. And so, if we just look at these individual ones, all we have in our first image does not look correct at all. Neither does this one, neither does this one. This one, if you look at it, it's not describing linear behavior in the y direction. The behavior in all of the directions seems to be sinusoidal. And so this is not going to be correct. If you look at this one, it isn't describing linear behavior in y either. And so this is not going to be correct either, which only leaves us with 2. Let's just look at 2. In 2, we see sinusoidal behavior in the z direction. We see sinusoidal behavior in the x direction, and in the y direction, it's just increasing linearly. And so that means that our second one is going to be our best option. And that's going to be it. So graph 2 is correct. Sorry, just one moment for the question to load. Okay, next up, we want to figure out what the integral here is. We have the integral of 1 over 1 plus x squared over dx. We're going to be using substitution here. We're going to state x is equal to tan of theta, which means dx over d theta is going to give us secant squared theta. I can quickly prove this for you using the quotient rule if you'd like to see that, where we find d over dx of tan theta is the same thing as d over dx of sine theta over cos theta. Sorry, d over d theta. And that is going to give you the derivative of this top one, so cos theta by g of x, which is cos theta in this case, so cos theta, minus this one, just the way that it is, multiplied by the derivative of cos theta, which is negative sine theta, all over cos squared theta. This is going to give us cos squared theta plus sine squared theta over cos squared theta, which is 1 over cos squared theta because of this identity. And this is just going to be secant squared theta as shown here. And so that is correct. And so we will have that, dx is equal to secant squared theta d theta. And so we're just going to put that all back in, and we'll get the integral of 1 over 1 plus tan squared theta into secant squared theta d theta. We also have the additional identity of 1 plus tan squared theta is equal to secant squared theta. And so this will become the integral of secant squared theta over secant squared theta over d theta, which is just the integral of d theta, which will give us theta. Now we need to find theta from our first substitution, if x is equal to tan theta, that is the same thing as theta is equal to inverse tan of x. And so we want to write theta in terms of x, which we have done here. So we get that theta is equal to the inverse tan of x. And then don't forget about our plus c because of the unbounded integral. And that's going to be our final answer. Next up, we want to find the Taylor series for cos x. And so our formula for the Taylor series is the summation evaluated at a over n factorial by x minus a to the power of n. For simplicity, we're just going to choose the point a is equal to 0. So this will become the summation from n is equal to 0 from infinity of fn evaluated at 0 n factorial x to the power of n. So let's go about finding the first couple of derivatives. So f0 x equals cos x evaluated at 0. That's going to be the cos of 0, which is 1. The first derivative is going to be negative sine x evaluated at 0. That is going to give us 0. The second derivative is going to be negative cos x evaluated at 0. That is going to be negative 1. The third derivative is going to be sine x evaluated at 0. That is going to be 0. Fourth derivative is going to be cos x evaluated at 0. That is going to be 1. And so now let's start with that. And we will find that f of x is equal to, so f of 0 evaluated at 0 over 0 factorial x to the power of 0 plus the first one, 0 over 1 factorial x to the power of 1 plus negative 1 x squared over 2 factorial plus the third one, so here 0 x cubed over 3 factorial plus 1 x to the power of 4 over 4 factorial. So we see that all of these odd powered terms are going to cancel out, and we'll only be left with x to the power of 0. This is all going to be 1 minus x squared over 2 factorial plus x to the power of 4 over 4 factorial, and we'll actually keep seeing this pattern repeat with minus x to the power of 4 over 6 factorial plus x to the power of 8 over 8 factorial, so on and so forth. And if we try and summarize this pattern with another summation, we find that the pattern is going to be the summation from n is equal to 0 to infinity, negative 1 to the power of n, x to the power of 2n over 2n factorial. Just to show that this is right, when n is equal to 0, this would be equal to negative 1, 0, x to the power of 0 over 0 factorial. Negative 1 to the power of 0 is 1, so that's going to give us our first term. Then you're going to get negative 1 to the power of 1, x to the power of 2 over 2 by 1 factorial. So negative x squared over 2 factorial. So you see our first terms are correct. Our fourth term will be negative 1 to the power of, our third term. So this is our 0, so n is equal to 0, n is equal to 1. So now let's do n is equal to 2. And we'll get negative 1 to the power of 2, x to the power of 2 by 2, which is 4, over 4 factorial. And this will give us x to the power of 4 over 4 factorial. This is going to become a positive 1. And so this is going to be plus x to the power of 4 over 4 factorial. And if you continue just testing your terms, you'll see that this is the pattern that is developed. And so this Taylor series representation is correct. And this is going to be your final answer. F of x, which is cos x, can be represented by the Taylor series from n is equal to 0 to infinity, negative 1 to the power of n, x to the power of 2n over 2n factorial. And that's going to be your final answer. Next up, we want to evaluate this integral. We want the integral of cos squared x. We're going to use the identity that cos squared x is equal to 1 plus cos 2x all over 2. We're just going to plug that right back in. And we'll get that the integral of cos squared x is equal to the integral of 1 plus cos 2x over 2 all over dx. Okay, next up we're going to use a property that the integral of some constant multiplied by f of x over dx is equal to the same thing as pulling out that constant. And we're going to apply that to pull out the 1 over 2. Next up, we will use another integral property, that the integral of f of x plus g of x all over dx is going to give us the integral of f of x dx plus the integral of g of x dx. And we're going to apply that just to separate this out. And so we'll get the integral of cos squared x is equal to 1 over 2 into the integral of 1 dx plus the integral of cos 2x dx. And then this one, we already know what it's going to be. This, we're going to use substitution to find it. And you'll see that if you set u is equal to 2x, then du over dx will give us 2, which means that dx is equal to du over 2. So the integral of cos u, because u is equal to 2x, du over 2, we're going to pull out the 1 over 2. So it becomes cos u du. And the integral of cos u, we already know that that is going to be sine of u. And then you just put in what u is, so sine of 2x. And so we're just going to put all of that, including what we know this to be, which is x, back in. And we find that the integral of cos squared x over dx is going to be 1 over 2 into x plus 1 over 2 sine 2x. We're going to have a plus c, but let's put that outside because this is an unbounded integral. And then we can leave it in the simplified form or write this out as 1 so that it can become 2x plus sine 2x all over 4 plus c. And that's going to be your final answer. Next up, we would like to find an equation of the tangent plane to the given parametric surface at the specified point. Graph the surface and the tangent plane. And so we are given r uv is equal to u squared 2u sine v u cos v. And so first off, we're going to want to find the derivative with respect to u and v. Cross those two to find the plane perpendicular, so you're n, and then you're going to do r dot n in order to find our answer. So let's go about doing that. Ru is going to be 2u 2 sine v cos v. Rv is going to be 0 2u cos v negative u sine v. Next up, we are going to want to cross them. And so Ru cross Rv my apologies. You'll have I, J, K, and then you're just going to put in Ru here, and then we're going to put in Rv right beneath it. And that is going to become negative 2ui plus 2u squared. Sorry. So negative 2u squared sine v, and 4u squared cos v as your answer. Because in the I, you're going to have 2 sine v multiplied by negative u sine v, plus in the j, you're going to have, this minus this. Sorry, let's just write it out so you can understand what's actually happening. So in I, you're going to have 2 sine v by negative u sine v minus cos v by 2u cos v. So in the I, you'll have 2 sine, so negative 2u sine squared v minus 2u cos squared v. If we factor out the negative 2, you get sine squared plus cos squared, which we know is 1. And so that's how you get the negative 2. So in I, we have negative 2u. So in I, we have negative 2u. In j, we will have 2u by negative u sine v, the negative of this, multiplied by cos v by 0. So minus cos v by 0. And this will become minus negative 2u squared sine v minus 0. And this is just 2u squared sine v. So that's how you get this j component that you see here. And so if you put that in, you get 2u squared sine v. And lastly, in our k spot, we will have 2u by 2u cos v minus 2 sine v by 0. And this is just 4u squared cos v. And that's how you get this 4u squared cos v. And so we get that RU cross RV is equal to negative 2u squared sine v, 4u squared cos v. So this is going to be our normal vector. Then next up, you want to evaluate our normal vector at the asked point. So we are asked at u is equal to 1 and v is equal to 0. It's in the question. And that is going to be negative 2. Sine 0 is going to give us 0. So negative 2, 0 in this spot. Cos 0 is going to give us 1. So, and then by 4u squared. So 4 by 1 squared is 4. Next up, you want to evaluate r at the required spots. And that would be, if we just go back to our r, we get u squared, so 1 squared. 2 by u, so 2 by sine 0, which is going to give us 0. And lastly, u cos v, which is going to give us 1. And so, next up, in order to find our equation of this plane, we are going to take r minus a dot n, and these are going to be our a values. And so it's going to become x minus 1 multiplied by negative 2, so your first n value, plus y minus 0 multiplied by 0, plus z minus 1 multiplied by 4 is equal to 0. This will become negative 2x plus 2 plus 4z minus 4 is equal to 0. And then we can just write out everything. Negative 2x plus 2 minus 4z minus 4 is equal to 0. This is positive. And so 2 minus 4 is negative 2, so negative 2x plus 4z minus 2 is equal to 0. We can divide both sides by negative 2 so that we can get a positive coefficient for the for the x. So over negative 2, and this becomes x minus 2z plus 1 is equal to 0 as your final equation of the tangent plane. And then if you want to graph it, you can really use any online 3D graphing calculator. Like GeoGebra. And then we can just type in what we have. So x minus 2z plus 1 equals 0. And so that's going to be the tangent plane to the surface. And so our surface is here and the tangent plane that we just found in GeoGebra. And that's going to be it for this question. Next up, we want to find the derivative of cos squared x. So we can use two methods. First, we can see this as cos x by cos x, and we know that the derivative of u, so some function of x by another function of x, is going to be the derivative of the first one, you leave the second one alone, plus the derivative of the second one, and this time we leave the first one alone. And so if u of x is equal to cos x, and g of x is equal to cos x, both of their derivatives will be negative sin x. Plug that all back into here. And we get that the derivative of cos x by cos x is negative sin x over cos x plus negative sin x by cos x. This will give you negative 2 sin x cos x, and that's going to be your final answer. Alternatively, you can use substitution, and you can state that y is equal to u squared, u is equal to cos x. So dy over dx will be dy over du multiplied by du over dx. Dy over du, you're just going to drop the power and subtract it. And du over dx is negative sin x. And so we get that dy over dx is equal to 2u by negative sin x. And then we just put in that u is equal to cos x. So we get negative 2 cos x sin x, which was our exact result from before. So the second method is a bit easier if you know typical rules when it comes to derivatives. If you're still in the early chapters of derivatives and you're just finding out how to do them, then you use this method. And that's it for this question. Okay, those are all of the questions that I have for you today. I hope you enjoyed today's stream. If you would like to be notified of when we do post, be sure to hit the subscribe button and the bell next to it so you can get the notification that we have just posted. If you'd like to be able to have questions of your own on the live stream, be sure to check out the links in the description. This has been Marlyn from OneClass, and I hope to